So, guys, welcome to Mech Talks. Mech Talks is all about mechanizing times, and I'm your host, AH, Aka Action Hero. And this show is hosted by AH Technologies. So, guys, Mech Talks talks about mechanical engineering and its various related branches, and they may be automobile engineering, material science, mechatronics, and also robotics, and also a lot of related stuff, which is also very much interesting. So guys, before moving on to the topic, I just request you to please do subscribe my channel, and at the same time please do like and share my video. So today's topic is about microprocessor versus microcontrollers. So in today's topic I'll be just giving the gist about the microprocessor and the microcontroller, and also the basic difference between both of them. So, and also we'll be talking about their applications. So let's begin with the microprocessor. If we begin with the microprocessor is a kind of a chip that is used in computers, smartphones, and supercomputers, and also other kind of devices which require high processing power, and also have to perform random tasks set by the user instantly. So such demanding works require microprocessors. So let's talk about the applications of the microprocessor. So if we talk about the applications of a microprocessor, for example, document creation for office work, and also to perform graphics and animation, gaming and web browsing, online audio and video streaming, computer aided drafting and 3D modeling, simulation and research activities, and also complex mathematical calculations require a microprocessor, because these tasks are really highly demanding, and at the same time they require high processing powers. So guys, these are the examples like gaming, for example, the recent games like PUBG or other kind of sort of games which require heavy rams and heavy processing powers, and at the same time the CAD modeling activities, for example, and architectural team requires to design a specialized building or a concept building, so they do it in a modeling software, and these modeling softwares really require a highly demanding processing power. So the next thing is the documentation. Even though the documentation doesn't require a lot of processing power, but it's also a demanding thing. It may require a 700 megahertz processing power. So at least most of the general day computers are having a processing power of approximately 2 gigahertz to 3 gigahertz. So at the same time, most of the research activities have complicated mathematical problems, and also simulation activities which require a high demanding processing power. So such activities use a microprocessor. So let's move on to the microcontroller. So actually, what is a microcontroller? So a microcontroller is a integrated chip or an integrated circuit that has low processing power, and is designed to perform only specific tasks, and it has also very low computing power. So these microcontrollers actually help to replace the microprocessor, to replace the expensive computers to perform some small tasks or basic tasks. For example, they may be like small controlling operations. For example, if we take a coffee vending machine, so a coffee vending machine doesn't require a expensive computer by its side to just vend the coffee. So such a kind of for such a kind of task we require very less processing power and low computing processes. So that's the reason we use microcontrollers in such kind of applications. So let's see what are the applications of microcontrollers. So if we talk about the applications of the microcontrollers, most of the electronic appliances like ovens, automatic washing machines, air conditioners, and refrigerators have these microcontrollers. Actually, if we talk about air conditioners, for example, if you want to set the temperature of your room, you could be setting it to 16 degrees centigrade. So if you want to set such a kind of temperature, you require a controlling device over there. For such a kind of controlling operation, which is very simple, you don't require an expensive computer. So in such cases, we will be using the microcontrollers, and these microcontrollers really have very low processing power. That's the reason they are also cheap. At the same time, there are also other devices like MP3 players, gaming consoles, Bluetooth speakers, toys, coffee vending machines, as I said before. At the same time, the microcontroller chips are also seen in printers, mouse, keyboards, etc. At the same time, you can also see in the mechatronic devices and automation devices. For example, if we talk about an engine control unit or the ECU which is being used to control the engines in the recent days, it's really have become a popular thing. So such kind of ECU controlling device requires a small kind of electronic chip, and this electronic chip is a microcontroller which controls the flow of the which controls the injection of the fuel into the engine and also other kind of parameters. These things are such a kind of microcontroller actually increases the efficiency of a product. At the same time, it may also be used as an accessory. For example, if we talk about increasing the efficiency of a product, I've just spoke about the engines recently being used. So for improving the efficiency, the fuel efficiency of an engine, recently we have been using ECU. So this is the best example for a microcontroller. At the same time, in the recent days, drones and other kind of small scale robotic projects use microcontrollers. So these are the examples of where the microcontrollers are being applied. So one is the oven, fridge, washing machine. Next is a small robot, a camera, and at the same time a drone. So guys, now we will be talking about the difference between microprocessor versus microcontrollers. So microprocessor is actually a CPU. It's a standalone CPU, and at the same time the RAM, ROM, and IO ports are externally connected to the CPU or the microprocessor. When we talk about a microcontroller, the CPU, RAM, ROM, IO ports, and the timers are all inbuilt with the microcontroller. So the other main advantage of the microprocessor is that the designer can decide to have how much of RAM or ROM or the IO ports required for the microprocessor. But in case of the microcontroller, it's really difficult because the IO ports, the RAM, ROM are already predefined and are already fixed with the microcontroller itself. So they are inbuilt. When it comes to the expensive nature, actually a microprocessor is really highly expensive. It may cost from thousands to lakh. For example, the recent Intel iCore 9 processor is costing around 1 lakh rupees. While if we talk about microcontrollers, actually these microcontrollers are very cheap when in comparison to the microprocessors. So if we talk about the versatility, microprocessor can be applied in various kind of applications because microprocessor is used for only for the processing a set of data. So it can be used wherever the processing power is demanding. But when it comes to the case of microcontrollers, actually they are only used for a single purpose. For example, if you take an oven, if you want to set a temperature, so to set a certain temperature you just require a single task, so it's a single task. So that's the reason you don't require any kind of highly demanding or highly heavily processing powered microprocessor. You require a low computing microcontroller. So microcontroller are being used in ovens. So as I told you earlier in the examples, at the same time, microprocessor has a higher processing power. When compared to microcontroller, it has low processing power. If we talk about the processing powers, for example, the microprocessor has a processing power of ranging from 700 megahertz to around 5 gigahertz and also so on. When it comes to microcontroller, it can be from 1 megahertz to around 72 megahertz and so on. So when we talk about the power consumption of a microprocessor, in comparison to microcontroller, a microprocessor consumes more power while a microcontroller consumes less power because it doesn't process a lot of tasks. So the power consumption is natural. For example, if you take a microprocessor, it has a lot of processing power, so it consumes a lot of power. When it comes to the microcontroller, it does very small tasks, so very little bit of operations, so it will be consuming less power. So when we talk about the its processing, this microprocessor actually has the instruction sets focused on processing intensive operations. For example, CAD level or simulation programs, they require an intensive operations. But in case of microcontrollers, if we talk about the processing, they only focus on bit level operation and also controls, simple controls. When it comes to the microprocessor, they may be 32-bit or 64-bit, but when it comes to microcontrollers, typically they are 8 or 16-bit. Also, the deep microprocessors typically have a deep pipeline, and they may be around 5 to 20 stages. But when it comes to microcontrollers, they are only used for single task. So that's the reason they have typically single cycle or two-stage pipelines. So now we'll be talking about the internal structure of a microprocessor and microcontroller. So if we see here the internal structure of microprocessor, so in a microprocessor you will be having only a standalone CPU. So the CPU contains the ALU, arithmetic logical unit, control unit, and also the registers. So when we talk about a microcontroller, actually a microcontroller controls has a CPU itself, and at the same time it also has the IO ports, also the counters, timers, RAM and ROM inbuilt with it. So a microcontroller actually is a small kind of a very small chip which has both the RAM, ROM, counters, timers, CPU, and also the IO ports. But while when it comes to the microprocessor is only a CPU. While this CPU needs to be connected with the motherboard to perform the tasks. But an IC can be used wherever you want. For example, the IC is nothing but a microcontroller. So let's move on to the other topic. So it's time to conclude the topic, guys. So let's talk about the summary. Um So if we start with the parameters, so first I have talked about the applications. So microprocessors are mostly used in gaming, web browsing, documentation, etc. When it comes to microcontrollers, they are mostly used for specific tasks like cameras, washing machines, etc. And when we talk about the internal structure, a microprocessor has the has has to be connected with the memory and IO ports externally, while a microcontroller has the CPU, memory, and IO ports present internally. So when it comes to the cost, a microprocessor is highly expensive, while it comes to my controllers, they are less expensive. Microcontrollers. When it comes to the power consumption, microprocessors consume more power, and when it comes to microcontrollers, they consume very less power. And also the storage, so microprocessors can have a storage of hard disk like 128 GB to 2 TB. When it comes to the microcontroller, the range is about the flash memory is like 32 KB to 2 MB. When we talk about the external peripherals or interfaces being connected to these devices, if we talk about microprocessors, like we can connect it with an USB, UART, high speed Ethernet. When it comes to the microcontrollers, the peripherals are like UART and I2C, SPI, so on. So this is all about the microcontrollers versus microprocessors, guys. I hope you have understood what is a microprocessor and what is a microcontroller. So thank you, guys. I thank you all for watching my video and also visiting Mech Talks. And at the same time, please do like and share my video and do comment in the comment section, please. And also don't forget to subscribe my channel.